Welcome students and teachers. This video is about a very fascinating planet. Chances are if we ask you to draw any planet, you will draw something similar. A planet that has caught attention of many civilization and curious minds. Let's explore what this planet has to offer us. So let's look into it. So the tilt of axis of rotation with respect to its orbital plane is somewhat similar to that of Earth, which is roughly 26 degree, and because of that Saturn also experiences seasons, but unlike Earth season, which are few months in span, because Saturn orbits around once every 30 years, so its seasons are quite a bit long. So its seasons span for about 7 to 8 years. Being roughly 10 astronomical unit away from the sun, it receives quite less sunlight, and therefore we should expect that the temperatures associated with Saturn would be less. We will look into that. Relatively, just like that of Jupiter, Saturn rotates quite rapidly, and it finishes one rotation in almost 10 hours, because of which it has slightly squashed shape near the poles. Around the poles it is slightly squashed and it is bulged around the equator, and just as we expect, the rings are along the equatorial plane. So let's compare some of the features with respect to Earth, but I think Earth is not much to scale. Let's change that. Excellent. So compared to Earth, Saturn has mass roughly 95 times, which is huge, which makes it the second largest planet and a gas giant. For gaseous planets, they do not have surfaces, so it is hard to define a radius, but we could say at roughly the radius where the pressure is around 1 bar or 1 atmosphere approximately, the average radius is about that of 9 times that of Earth. So you could fit in 9 such Earth along its equator and probably around 8 around pole to pole. So because escape velocity of Saturn is quite huge, roughly 35 km per second, so whatever asteroids or other particles it captures, they remain in this Saturnian systems, and the number of moons that we keep on discover increases. Currently at the time of this recording, it has approximately 146. One of the key feature, as you would observe in many literature, is that average density of Saturn is less than that of water. So the joke goes, Saturn would float in a solar system size water tub. However, keep that in mind, these things are just joke. Saturn is not uniformly of the same density. Core is much dense with metallic composition, and because of the high mass and the gravity that attracts this entire mass together, increases the interior pressure and temperature so much that the hydrogen within the interior starts acting like metallic hydrogen, which means it can conduct electricity, and that allows it to have a slightly weak magnetic field, but enough to form some aurora just like we see on Earth. So Saturn also has some of them. It is also composed of hydrogen and helium. Most of this upper atmosphere consists of that, where we see many of those cloud bands and other features. It has a very prominent ring, mostly because it is quite dense, and that allows significant reflection of light to reach even from Earth based observation, and typically the names are not very creative. It goes from A to G in order of their discoveries. Because of this high temperature and pressure caused by force of gravity, it radiates more heat than it receives from the sun. So next time someone tells you this joke, just remind them that the core will probably gravitationally interact with the water and some of the gaseous element will escape away, or you could just laugh at that joke, it does not matter. Coming back to the ring system, which is one of the most prominent one in the solar system, in all the gaseous planets, you would notice there are some gaps in this ring system. It is not continuous throughout, and for some time it was challenged to figure out what causes these gaps, but currently we know that there are some moons which we call shepherd moons that orbit around the rings in such a way that their gravitational tug maintains some of these gap and keeps the shape of the rings as we know it. So however, one more thing to consider, rings of Saturn are not continuous as we see in many of the models or images, they are made up of many tiny rock and dust particles. Most of these particles are ice particles or remainder of asteroid and comet collision. Although it spans for quite a large distance, their average thickness is pretty low. It varies around 10 meter to 1 kilometer, order of 1 kilometer thickness, and scientists have divided them into different categories, and and their shapes are mostly guided by some of the nearby moons. Right. So, since Saturn has a weak magnetic field, slightly weaker than that of Earth, that magnetic field allows the charged particles coming from the sun to be trapped and ionize the gases around the poles, and that is what causes that beautiful lights and aurora that we see both on Earth or on Saturn. Surprisingly, the axis of magnetic field of Saturn is very closely paired with the rotational axis. It is not common in other planets, but that is that also tells us something, that also tells the scientist how perhaps this planet would have been formed. Most common explanation for this rings formation is perhaps several moon or asteroids, they collided near the Saturn, and they were gravitationally bounded by the Saturn. We still require more observation to come up better understanding of this, how the ring system was formed. So, because of this magnetic field, we see such auroras which cover quite a large angular size. We observe these beautiful aurora like patterns. On similar note, we also see from an independent event that Saturn's polar region has this very near hexagonal shaped storm. It was quite surprising at the time of its discovery that how come such a regular shaped hexagon could be part of natural dynamics, but more and more observation has revealed the kind of storms and cloud like patterns responsible for such shape. Lastly, coming to different space missions that have been to Saturn. So, Saturn has been approached by 4 space missions so far. First one was the Pioneer 11 in late 1970s. This was a flyby mission. For the first time, it was able to take detailed photographs of rings and the Saturn. Then Voyager 1 and 2 followed in 1980s, and this is where the initial detailed observation actually began. But the bulk of the information that we have collected is from the Cassini-Huygens mission. It orbited around Saturn for around 13 years and gathered much of the data about Saturn, its clouds, rings and its moons. There are some proposed mission by China and NASA to launch for landing and flyby at the time of this recording. So, coming to the moons of Saturn, we see some regular moons that orbit in the same direction as the rotation of Saturn. Some of the prominent ones are like Titan, Mimas, Enceladus, but Saturn being a gravitationally dominant object, it also captures much of the irregular moon's orbit. The red ones shown in this figure are the retrograde moons, that is, they orbit in the opposite direction that of the rotation of the Saturn, and likely they were captured from some other celestial event. So, this one of the nearby moon Enceladus, what we observe is that it has very cold volcanic like eruptions. So, mostly ice, waters similar to Io erupts, and even though these planets receive much less sunlight, but due to the tidal heating being close to Saturn, that is because of stretching and squeezing being near Saturn, allows its interior to be hot enough to have these active geology. Even some of the volcanoes eruptions were observed, and several missions have recorded organic compounds. So, given there are some organic compounds and significant heat into the system, some of the scientists suspect there may be life in this moon. But one of the highlight in past missions was landing on the farthest solar system object till date is this of Huygens mission by European Space Agency, that was part of the Cassini mission, and it successfully landed and recorded several features of Titan. It observed there were lakes, there were rivers, it had weather like and also rain. But before you plan any holidays to that, remember these are not regular rivers and lakes that we see on Earth. These are liquefied methane and other gaseous rivers. So, it is quite cold, but we still believe that some of the conditions may be right for a different kind of microbial life there. So, future missions like Dragonfly will be looking for some more signatures. Before we end, there is some interesting fact about Cassini. So, before Cassini was about to lose all its fuel and would have lost all the control, what scientists did, instead of allowing it to crash anywhere in Saturn or on the moon, they purposefully crashed it on Saturn. Why? Because they were apprehensive, or they worried that any microbial life on Cassini may contaminate any other microbial life in nearby moon, and that could have caused several challenges in future missions to search for extraterrestrial life. So, it was purposefully deorbited within the Saturn, and now molecules of Cassini are part of the Saturn's atmosphere. That is all from this video. If there are any doubts or comments, or you like to know about any other topic, do let us know in the comments. Thank you.